Hi guys, in today's video I would like to share with you this feed-forward neural network that I've made in Java. This one is also available on my GitHub page, and basically the way it works, it has three files with topology where you define number of input nodes, some hidden layers, and number of output nodes. And this neural network has supervised training, so it needs training data where basically one line is one training sample, or basically one training situation in which it tries to iterate, and when the training is done it saves all the weights and biases into this weights.txt file. So this is basically it. I create new training data, I load the topology, create neural network based on that topology, and it's easy calculation how you can check if number of weights in this file matches with this topology. And if it does, then the training is skipped, because this condition says is if weight size doesn't match with number of weights from the file. So if these weights doesn't match by their count with this vector created basically from the topology, then it needs to retrain if it doesn't match, and if it does, then the training can be skipped and just weights are loaded from that file into the topology and it can run. So I can easily demonstrate it. I can run this, and as you can see, now it runs. It didn't train, so I can stop this and show it to you as a proof. All the way up here, this neural network project just opened and closed several times files, then created all the neurons needed based on that topology, and weights were loaded from the file, and it started a run mode. But now I can minimize this and I can demonstrate this second part, when just this first part basically where the number of weights doesn't match with the number of weights loaded from the file. So when I delete these weights, they also won't match anymore. So this neural network needs to train. Okay, so the training is done. I can stop this, and we can check up here that in this case it needed 2000 training attempts to minimize the error. So as you can see, it was training all the time. It was pretty quick training because the topology was quite fine for this type of work, and this is basically some simple example for a neural network. And by the way, this neural network was basically rewritten from my C++ version, so these mostly look alike, and I have both versions of this neural network shared on my GitHub page. So I have also available this C++ version and also this Java version. they work the same way. They read and save all the values from and into the files. So that's how they work. So this is the C++ version on my GitHub page. This one is Java version, and I also uploaded here zip file where I have simplified version of this neural network, where it trains all the time because it doesn't have these files. That simple version, I can show you. It only creates the topology and needs to do training all the time. Because in this case, I have training data in these variables, the Java file, and I have no files from which to load them. So this looks quite easier and quite different, but this just lacks these functions that can save and load the data and so on. So that's why this is the simplest version of this feed-forward neural network. So I can show you that it needs to train all the time. Yeah, there was the training, now it's done. So in this case, it needed to pass it over 4,700 times. So this was the simple version, and this is the version with the files. So in here I have all the weights and stuff. Basically, this one uses linked list for inputs and for all the variables. And by the way, this C++ version I also used for STM32 project for my Neurobot project. So if you want, you can go on and watch my video, which is available on YouTube.
Hi guys.
So that's all for today. I will share all these links down below in the description. So thank you. Bye.